This video is going to talk about the quadratic formula and the discriminant. We can use the quadratic formula to solve quadratic equations. Before we talk about the quadratic formula, let's review the quadratics. Right? Quadratics make that U shape when we graph them, and that U shape is called a parabola. It could be a right side up U or an upside down U. Okay, you have three options for how many solutions a quadratic can have. Okay, if your quadratic is completely above the x-axis and never crosses, you're going to have no solution. If it never crosses the x-axis, or if it's completely below and opens upside down, you can have it cross twice. Everywhere it crosses is a solution. So if it crosses twice, that means you have two solutions to your quadratic. And you can have it touch it one time at the vertex. You have one time that it touches and crosses the x-axis, and that is where you have one solution. You cannot have more than two solutions with a quadratic. So you can have one solution, two solutions, or no solutions. The quadratic formula is what we use to help find those solutions. It always works no matter what kind of equation you have. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You have to keep in mind your quadratic has to be in this form ax squared plus bx plus c. That's standard form. Okay, it's got to be in standard form. Standard form of a quadratic is very similar to standard form of a linear, but we have this x squared in there. Right, standard form not only has ax squared plus bx plus c, but it's also set equal to 0. Everything has to be on one side of the equation in order for the quadratic formula to work. Once you have it in standard form, you just plug in a, b, and c. That's just a coefficient. So the coefficient of x squared is your a, the coefficient of x is b, and your constant is c. A specific part of the quadratic formula is this part underneath the radical. That's called the discriminant. The discriminant can tell us how many solutions our quadratic has without actually having to plug everything in. So this discriminant is just b squared minus 4ac. If we plug in numbers, our a, b, and c, if we plug them in to our discriminant and we get a positive number, okay, so if we plug it in and get a positive 40, that tells us that we have two solutions. All right, so a positive discriminant tells us we have two solutions. If we plug everything in and we get 0 for our discriminant, right, if our discriminant works out to be 0, that means we have one solution. And if we plug everything in and we have a negative, that means we have 0 solutions, because we can't take the square root of a negative number. So a positive is two solutions, 0 is one solution, and a negative is 0 solutions. We can be a little more specific. If we plug in and we get a positive, we know we're going to have two solutions, but we can decide if it's going to be rational or irrational. Rational are nice numbers that can be written as a fraction. Okay, so we can't write like pi as a fraction. It's a never-ending decimal. Okay, so if we plug something in and it's a perfect square, like 4, 16, 36, okay, if it's a perfect square, we know it's going to be rational because we can simplify that and we'd be able to write this as a fraction. If we plug it in and it's not a perfect square, that means we can't take the square root and get a pretty number, so it's going to be an irrational solution. Right? If we get 0, the square root of 0 is 0, so that means this whole radical goes away and we're left with a fraction, so one solution is always going to be a rational solution. So let's look at a couple of examples. Okay, if we have x squared plus 13x minus 30, okay, our a is 1, b is 13, and c is negative 30. So all we're going to do is we want to determine what type and how many solutions we have. We're going to use our discriminant. And our discriminant is b squared minus 4ac. Okay, so we're just going to say 13 squared minus 4 times 1 times negative 30. 13 squared is 169. 4 times 1 is 4. And negative 4 times negative 30 is positive 120. 169 plus 120 gives us 289. And the square root of 289 is 17. Alright, so this is a positive, so we know automatically there's two solutions just because it's positive. And because it's a perfect square, we know that these are going to be rational. So two rational solutions. Looking at number 2. Our A is 1, B is negative 22, and C is 121. So if we plug it into B squared minus 4AC, we have negative 22 squared minus 4 times 1 times 121. Remember, B squared is always going to be positive, because a negative squared is a positive and a positive squared is a positive. 22 squared is 484. Negative 4 times 1 times 121 is also 484. And 484 minus 484 is 0. So we know that we have one solution because our discriminant is 0. And because we only have one solution, it's always going to be rational. Alright, now we have x squared minus 5x plus 3. Our A is 1, B is negative 5, and C is 3. Plug it into B squared minus 4AC. We have negative 5 squared minus 4 times 1 times 3. Negative 5 squared is 25. 4 times 1 times 3 is negative 12. 25 minus 12 is 13. So it's positive. We know we have two solutions. But because 13 is not a perfect square, they're going to be irrational solutions. Alright, and number 4, A is 1, B is negative 6, C is 13. If we plug it into our discriminant, we've got negative 6 squared minus 4 times 1 times 13. Negative 6 squared is 36. Negative 4 times 1 times 13 is 52. And 36 minus 52 gives us negative 16. We cannot take the square root of a negative, so anytime we have a negative, we know that is no solution. Alright, now that we've used the discriminant, we're going to use the quadratic formula. So we're going to go all the way and solve each quadratic. So we'll start with that first one again. X squared plus 13x minus 30 equals 0. We know our A is 1, B is 13, C is negative 30. We know our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is something that you have to memorize. So if we start with our negative b, it's going to be negative 13 plus or minus the square root, and then we have 13 squared minus 4 times 1 times negative 30 all over 2 times 1. So then we have negative 13 plus or minus the square root of 169 plus 120 all over 2. Then we have negative 13 plus or minus the square root of 289 all over 2. Like we said earlier, 289 is a perfect square. The square root is 17. So we can say negative 13 plus or minus 17 over 2. Now, once you've simplified it all the way down to this plus or minus, that's where we get our two solutions from. Alright, so once we simplify as far as we can, then we can break it apart. We can say negative 13 plus 17 divided by 2. And then negative 13 minus 17 divided by 2. Negative 13 plus 17 gives us 4. divided by 2 is 2. Negative 13 minus 17 is negative 30. Divided by 2 is negative 15. So our answers are 2 and negative 15. The second one we looked at, x squared minus 22x plus 121. A is 1, B is negative 22, and C is 121. All right, our formula is negative b plus or minus the square root, b squared minus 4ac, all over 2a. All right, negative b. Now we have a negative 22 plus or minus the square root of negative 22 squared minus 4 times 1 times 121 all over 2 times 1. Negative negative becomes positive. 22 squared is 484. And 4 times 1 times 121 is 484 all over 2. 484 minus 484 is 0. This is where our one solution comes in. If we take the square root of 0, we get 0. So our plus and minus, that gives us the two solutions. If we add 0 and subtract 0, we're doing the same thing. So this whole radical goes away. And we're just left with 22 over 2, which is 11. So we have one solution, and that's 11. The last one we're going to look at, x squared minus 5x plus 3. We know a is 1, b is negative 5, and c is 3. You got negative b plus or minus the square root, b squared minus 4ac all over 2a. So we have negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 3 all over 2 times 1. Negative 5 is a positive 5. 5 squared is 25. 4 times 1 times 3 is 12 all over 2. 25 minus 12 is 13. Because we cannot take the square root of 13, we're going to stop here. This is as simple as we can get it to go. We don't want to have any decimals or rounding. We want to keep our answers as exact as we can, and leaving it in radical form gives us that exact answer. So all you have to say for your solutions is 5 plus or minus the square root of 13 over 2. And that's it.